Question 3. Questions about chromium and its compound. Complete the full electron configuration of a chromium atom. So first of all, you've got to find out the mass, the atomic number or the proton number of a chromium atom. And it's 24. So if you look on a periodic table, it's 24. Now you might think that the 4s electrons go in before the 3d. First of all, that's the first thing to know. So you might go 2s2, 2p6, 3s2, so that's standard, and then 3p6, and then you might put 4s2, 3d4. But what a chromium atom does is it half fills the 4s and half fills 3d to become stable. So it takes, instead of 4s2, 3d4, it goes 4s1, uses one of those electrons to half fill the 3d level. Copper does the same and goes 4s1, 3d10, incidentally, to fully fill the 3d level. So a 3d level will become half full or fully full and will take an electron from the 4s to increase its stability. An atom has 2 more protons and 3 more neutrons than an atom of 52 Cr. So 52 Cr, if you actually look up chromium, again I've said it's got 24 protons, so it's got an atomic number or a proton number of 24. So it's got 24 protons if you look it up in the periodic table. Here, by subtraction, 52 take away 24 will give you the number of neutrons, so it's got 28 neutrons. Now it says, deduce the symbol of an atom that's got 2 more protons. Instead of 24, it's now got 26. And 3 more neutrons instead of 28. It's got 31. 31 add 26 is 57. So it's 5726 Fe. Sample of chromium contains 4 isotopes, relative atomic mass 52.09. Table shows the mass number and percentage abundance of 3 of these isotopes. So there's 4 isotopes and it shows 3, so there's 1 missing. So you've got the percentage abundance, which is how much there is, how common it is. So the 4th one, so we could add up these and subtract from 100 to work out that there's 3.6% that's missing. So that must be the abundance of the missing isotope. So it's 2.8, add 10.9, add 2.7, subtract from 100 gives 3.6%. Now it's asking for, after the percentage abundance, show by calculation the mass number of this isotope is 50. So we've got to prove that it's 50. Okay, so let's first of all imagine that we had 100 particles, 100 atoms. 82.8%, 82.8 particles out of the 100 have a mass number of 52, 10.9 out of the 100 have a mass number of 53, 2.7 out of the 100 have a mass number of 54, and 3.6% 3.6 out of the 100 have a mass number that I don't know. I'll call that mass Y. So this is the number of particles out of the 100 that I've got mass 52, so if I multiply those two together I'll find out the mass of these particles. Multiply 10.9 particles multiplied by mass of 53 will work out the mass of these particles. 2.7 multiplied by mass number of 54 will work out the mass of these particles, and I've got 3.6 particles of unknown mass Y. So my total mass, when I put it all together, and it tells me what my so my total mass is 5029.1 at 3.6 Y, where Y is the mass of this unknown particle. Now what's an average? An average is the total mass, I've worked that out, 5029.1 at 36 Y, divided by the number of particles. The number of particles is 100 because I've decided that. So 5029.1 at 3.6 Y divided by 100 equals the average, and we're given the average in there, 52.09. So now if I multiply both sides by 100, 5209 equals 5029.1 add 36y. Take the 5029 to the other side. 179.9 is 3.6y. Divide both sides by 3.6, and so I've now got y, which is the mass of the unknown particle, 49.97. Now mass number's got to be a whole number, so I'll round it up to 50 to 2 significant figures. Deduce the oxidation state of chromium in Cr2O7. Well, the oxidation state of an oxygen is -2. 7 minus 2 is -14, and there's 2 minuses left over. So the two Crs must be +12, because +12 take away -14 leaves 2 minus over. If the two Crs are +12, 2 Crs +12, each Cr must be +6. Iodide ions can be oxidized to iodine using Cr2O7 ions. Deduce a half equation so that the oxidation of iodide ions, they're I- to iodine. Now remember, iodine is I2. The halogens pair up in twos and form a covalent bond between each of their atoms to fill up their outer shells. So in group 7, so they need to gain 1, so they put 1 in each two. One atom, each atom puts 1 electron in each into a covalent bond, so forms I2. So we need 2 I minuses, and then a half equation has always got electrons. Well, there's 2 minuses on the left hand side, so I need to introduce 2 E minuses on the right hand side to balance the electrons. Deduce a half equation for the conversion in acidic solution. That's important. Acids produce H pluses, so we're going to need some H pluses of Cr2O7 ions to Cr3 plus. You'll see the problem. If I've not got H pluses, I've got Cr2O7 minus going to Cr3 pluses. Where would the oxygens go? They've got to go somewhere. So it tells me in the equation that Cr2O7 minuses make Cr3 pluses. So where do these oxygens go? And that's why you need H plus. So when you're balancing half equations, you're always allowed to put H pluses in there, and you're always allowed to make water. There are two things that you're allowed to always introduce, and it gives you a clue by saying acidic solution here anyway. So I've put H pluses in, made Cr3 pluses, and I've made some waters. Now let's have a look. Balancing it, 2 Crs, so 2 Crs there, 7 Os, 7 waters. That creates 14 H's. I need 14 H pluses. What have I got? Got 2 minus and 14 plus, so that gives me 12 plus on this side. I've got 6 plus on that side, so I need 6 electrons on the left hand side. Now I've got 6 pluses on each side. Use your answers from 3.5 and 3.6 to deduce the overall redox equation. So what I do is I take everything from the left, oh no I don't. First of all, I've got to balance the electrons. I've got two electrons in this one, and I've got 6 electrons in this one. I've got to get equal numbers of electrons so that I can cancel electrons. In my overall equation, I can't have any electrons, so the number of electrons have got to balance. So I've got to multiply everything through by 3. So 3 times 2I minus is 6I minus. 1I2 is 3I2 and makes 6 electrons. And then I add everything up on the left. So once I've multiplied this top one by 3, I've got 6I minuses on the left here. Anything else on the left in my other equation, because I'm adding this on as well? Cr2O7 2 minus 14H plus and 6 electrons. On the right hand side I've multiplied this by 3, remember, so I've got 3I2, 6 electrons, 2 Cr3 pluses and 7 waters. Now my electrons will cancel, and when my electrons cancel I end up with 6I minus Cr2O7 minus 14H plus makes 3I2, 2 Cr3 pluses and 7 waters.